Perfect. I'm going to explain the derivation of an ellipse. It's pretty wacky. It's a 3-page derivation. So just hang tight. I won't ask you to do on a test. Don't like ask me. Oh, this is going to be a test. No, it's not going to be a test. Maybe I'll do as an extra credit question. Might be kind of cool. Yeah, time. So yeah, it's a 3-page proof. So what's the definition of ellipse? Now, all you know about ellipse so far, maybe it's oval. It's like a circle that's oblong. But more specifically, this part I need you to focus. If you take any point on the ellipse, okay, say this point right here, and you say you have 2 fixed points, we call this the major axis. There are 2 axes. There's a small and a big. They're going to be different lengths, because if they're the same length, it wouldn't be an ellipse anymore. It would be a circle, right? Because then you have, equal distance all around. But on the major axis longer, that goes through the center of the ellipse. If you have 2 fixed points, we call them the foci. That's plural for focus. When I say focuses, that's kind of weird. Say foci. If you take the distance between that point, x and y, here, and to the other focus, those 2 sums of those 2 segments will always be a constant. So d1 plus d2 has to be a constant. That is the definition of an ellipse. So set of all points, which is sum of the distances, that's plural, from 2 fixed points called foci, is a constant. So d1 plus d2 has to be a constant. So then, knowing that, we can actually try to come up with the equation for that ellipse. It's going to look circular in nature. It's kind of like an x squared and a y squared. So I don't want you taking the formulas for granted. Let's understand why they work the way they do, right? So d1 will be from one point to one focus. d2 will be the point we're still looking on the ellipse to the other focus. Now, the other thing we need to keep in mind as well, the endpoints of the major axis, I'll call a comma 0, negative a comma 0. Get used to that. The endpoints of the minor axis, I'll call 0 comma b and 0 comma negative b. They'll always be true. And by the way, the major axis doesn't always have to be horizontal. Be vertical. That could happen. So you switch A and B as a result. So A doesn't always go for X, B doesn't always go for Y. Essentially what's happening is that A is the endpoint of the major axis, B is the endpoint of the minor axis. So this tells me the length of the major axis is how long in terms of A.
2x.
And 2B is the length of the minor axis. Good. Pretty good. Okay, if I use this as formula. And by the way, another thing too, just to throw more letters at you guys, the point's getting more complicated. This is from the center to either foci. It's called C. So this between the 2 foci is 2C. Okay, so that's another thing we have to keep in mind as well. I know it's crazy. All right, so that's negative C comes in, that's C comes in, that's x comma y. So if I do the distance for this one, we call it F1, that'd be x plus C squared plus y squared. This will be x minus C squared plus y minus 0 squared to get that. And remember, that's negative C, so x minus negative C, x minus C. These 2 segments have to be a constant. So this plus this has to be a constant. Okay, so now what, right? What do I do? Well, if you think about it, let's say I look at this point right here, right? This is kind of tricky, but how far is it from here to here? And how far is it from here to here? Well, so let's start from here to here. How far is it from this point to that point? How would I rate that? Good. Yeah, the same one I see. Awesome. Good. Let me actually put this on Zoom here. That's A minus C, 100% correct. So this distance is A minus C. Okay, how about this distance? What would that be? That's kind of tricky. It'd be A plus C. Because you're covering A and another C. Now, isn't this point on the ellipse itself? And doesn't that follow that same thing? Like the sum of the 2 distances have to be a constant. So if I have A minus C plus A plus C, what does that reduce to? So this has to equal 2A. That has to equal 2A. That's exactly what I did here. Say we need another equation. We could use A comma 0 as a point at which the sum of the distances from both foci to that is a constant. So you get 2A. Okay, cool. So you substitute. Now this is where the fun begins. It gets really fun. Told you, it's great. You move this over to the other side. One of the radicals up to you. Square both sides. That's cool. Squaring a radical goes away. Oh boy. That's nuts, right? Because when you square something with another radical, there's a 2A minus that. You have FOIL. So you got another radical. Another radical. Now you have 4 times that radical. Some terms drop out, the y squared dropped out. I'll isolate this new radical here. I probably should finish for you guys. I'll do the next part. I'll do that. So you guys, it'll be in school league. If you FOIL, clean up stuff, divide by -4a, you get all these terms to start canceling very nicely, do it correctly.
Excuse me. So you want whittling it down to this.
If you crack out 4, cross it off, or -4, you get all this junk. Square both sides again. You get this. You have a to the 4 power. It's kind of nuts, right? You have all this stuff here. I can move this a squared over to that side, or divide by a squared. It's up to you. But move it over, distributes.
Continue canceling things out. You stumble upon
this. Now here's the other thing that's kind of tricky too. C squared equals a squared minus b squared.
Remember what C and AB represented. Okay. Coming back up here again.
So this is C, right? This is A, this is B. I have to kind of think a little hard about this one, but I believe there's some sort of Pythagorean linear situation happening here.
I'm not 100% sure. I need to double check that. But for now, we'll just accept it as it is. Just know that C squared, C being the distance from the center to the focus, is a squared minus b squared. So we're just going to accept that for now. So if we substitute, replace c squared with a squared minus b squared, and then continue working it out, you stumble upon this.
X squared base squared plus y squared b squared is 1. That's the equation of ellipse. A is the distance from the center to the major endpoints. B is the distance from the center to the minor endpoints.
And this is when the vertical, and then you just reverse it if the vertical axis is major, just reverse it. And actually, I think this is the derivation of why c squared equals a squared minus b squared. Yeah, actually, if we take a look at 0 comma b,
8 comma 0, and if we do the same thing, the b1 b2 business here, we do the same thing. Let's see, you have 0 minus a c squared plus y minus 0, or b minus 0 squared, by hypotenuse of b. You get this. Okay, so if you assume, because that's the point of the ellipse, d1 and d2 will become this if you do 0 minus that, and then 0 comma b minus c comma 0. Then d1 and d2s, those have to equal each other. Oh, sorry, those have to be a constant. Set that equal to 2a. Yeah, you do want getting a squared equals c squared plus b squared. Okay.
So that's kind of crazy too. So that whole thing is a whole other thing. Now, I'm sure you guys will greatly appreciate that I do have a very condensed formula sheet that I'm still debating whether I'm going to give to you on the test or not. I don't know. Okay, I'll make a deal with you guys. If the Niners beat the Chiefs on Sunday, I'll give it to you guys.
And you won't change the difficulty.
Niners beat the Chiefs.
And you won't change the difficulty of the test.
If the Niners beat the Chiefs, okay. So everyone's a Niners fan on Sunday. All right.
And if they beat them to that score, I will get the 100. They beat them 24.
No, I don't gamble, so I'm not gonna do that.
If the Chiefs put no points up, everyone gets 100.
Maybe. We'll see.
No points.
If we end Patrick Mahomes' career. And a Taylor Swift breaks with Travis Kelce. Okay, if Taylor Swift breaks with Travis Kelce, then yes, I will. All right. Anyway, point being,
This is a nice condensed formula sheet. Okay.
That's why I treated it
So-
hard.
all right. Now let's go to the notes, guys. Okay. All right. Here we go. Okay, stop looking at fantasy football. All right.
Oh.
John, put the fantasy football away. All right. All right. So anyway, so this right now is equation of circle, right? Because it looks like this: x minus 4 squared plus y minus 3 squared equals 36. But notice it's written kind of like the ellipse equation as well, right? So if you think about it, the center's at 4 comma 3. I need more space. That was not smart. The center's at 4 comma 3. And if you go 6 away on each side, so this will be like a 10. That's at 4. -2. I gotta go 6 higher. So that's at 9. And -3, I think. I mean, you just get a circle, right? But you're going to use the same kind of technique for ellipses. Where instead, we're going to call this a squared. And we're going to call this b squared. Well, of course, a was 6 and b was also 6. So the way we're going to approach this a little differently for ellipses, we'll solve the same center. This will be the same thing. But then we're going to figure out how far we're going to go left and right and how far we're going to go up and down. And those won't be consistent. However far we go left and right won't be the same as however far we go up and down.
So A won't always equal B.
No. Right.
A equals B.
A equals B is a circle. Circle. So we rewrite the equation like this, which is true. This is the same thing, right? X minus 4 over 6 squared, y minus 3 over 6 squared, equals 1. But what if I decide to do a little change? What if I change the denominator of the first fraction from 6 to 2? Can't do that, right?
So we can use Desmos to work this out for us. And then the terminology I kind of already explained, but what I'll do right now, instead of using Desmos, we'll just kind of do it. So where's my center? Yeah, it's the same kind of thing. It's going to be x minus h squared, just so you know, over a squared. Actually, I'm going to reverse it and call it b squared. Where a is always bigger than b. So in this case, my a is going to be 6. And the major axis is going to be vertical in this case. Because the denominator is bigger for y than it is for x. That's how I know that. Minor axis will be horizontal here. I'll get to the center point. I already know that's 4, 3. We'll worry about vertices and co-vertices in just a moment. So my center is at 4, 3. So I have to go 6 up, 6 down. Also have to go 2 left, 2 right. And I'm going to get kind of a fancy on you guys here. Okay.
All right. So here we have an oval or ellipse. Okay. Going 2 left, 2 right, 6 up, 6 down. By the way, if I were to plug in 6, 3, that should work, right? Because 3 minus 3 is 0, it goes away. 6 minus 4 is 2. 2 over 2 squares 1. That works, right? Or if I plug in 2, 3, 2 minus 4 is negative 2 over 2, and negative 1 squared is still 1, plus 3 minus 3 over 6, 0 squared, still 0.
Okay.
That's right.
Yeah.
So how can you?
Guys, questions? Go, David.
We know A is greater than B, literally just because.
It just always is. Always is. Always. Yeah. So it's A's for major. Yeah.
A isn't necessarily for Y.
Yeah. So the vertices here are going to be the endpoints of the major axis. The covertices will be the endpoints of the minor axis. So I'll call this like V and V. I'll call it CV and CV. So your vertices are pretty obvious. They'll be 4, 9 and 4, -3. And the covertices should be pretty obvious. They'll be 6, 3 and 2, 3. And that's, I think, all they asked us to do. And if you think about it, your vertices are going to be, in this case, H, K plus A. That'd be your vertices in this case, if it's vertical. And your covertices would be H plus or minus B, A. Sorry, K. My bad. If it's minor. There's actually a really nice formation. And just give me a moment. I'll come back to this. We're still copying down. Maybe it's here. Precalculus. I think chapter 9. No. Chapter 8. No. Chapter 7. Okay, chapter 5. Nope. Hold on. Nope. Hold on.
A is always gonna be the major. A is always gonna be the major.
Here we go. Okay. This is what I was about to show you guys. So might help if actually I give you guys this format sheet. This actually is a little more detailed. We're told where the center is, up from vertices and the covertices, major horizontal or major vertical. And find the foci. But we did this for 2 levels below this class. I don't think I'm going to quite give that to you. That's too much because you guys are much stronger. It is beautiful. It is nice. Yeah. But as a reference, I might at least print. Actually, you know what?
Oh, the Chiefs beat the Niners.
Yeah, the Chiefs beat the Niners.
No, if Mahomes gets injured.
You know what happens if Patty Mahomes dies?
If Patty Mahomes dies, it's not good.
Well, he's coming here. You can control that. He's going to be down here. So you drive down to Levi's then. Sean, go ahead. Yeah. Here, let me print this for you guys at least. Correct. Yeah. Okay, I'm gonna print this just so you guys have a reference. Okay, let's get back to doing notes again, guys. All right, here we go. A question? Yes.
If you go to that Mila sheet, I don't understand how A is always greater than B, and then A for both of them is over. I mean, your Y is over A. I don't understand how that can make for a vertical ellipse.
Oh, because it's longer. Because you're in order to so in order to get like this 3, 9 or 4, 9 and 4, -3, when X is 4, Y would actually be a bigger number compared to the other way around, that when you made Y was 3 and trying to figure out what X is. So you're going 6 up and 6 down because of the 6 below. The bottom line is this: look at what's the denominator and look what coordinates associated with it and move in that direction. Right.
Then I'm saying, wouldn't or in order for something to be a horizontal,
then you need the other way around. Then the denominator of X has to be larger than the denominator of B of Y. Yeah, exactly.
Then I thought A squared is, I mean, A is always greater than B.
Yeah, exactly. So in that case, your A will now be below X.
I think that's what it said.
Oh, okay. No, I'm pretty sure it did. Did this sheet here? I'm pretty sure it says that.
Oh, it switched A and, oh, it's.
X and Y switch.
X and Y switch, okay.
Yeah, your eyes are playing tricks on
I
you,
get it
dude.
now.
Yeah, no worries. Actually, you would think to keep X and Y the same, and yeah,
Yeah.
I understand. Okay, guys, let's graph the next two, and then we're gonna move on. Okay, guys, stop talking. Let's keep moving here. All right. So your graph should look like this for 3a, 1, -2. And because you have 3 below x minus 1, you can go 3 left, 3 right. And 5 up, 5 down. Okay. And we have to state key features. That'd be the foci, the vertices, and the co-vertices, okay? Well, the vertices would be easy. That would be -2, 3. And -2, -7. Your co-vertices would be 4, -2. And -2, -2. Your foci would be, now for c squared. So c squared is 25 and b squared is 9. Remember, a was 5, right? A is 5. And b is 3. So c is 4. On the major. Yeah, always in the major. So it's -2, 2. And -2, -6. Is that right? The foci. Part A. Yeah. I'm sorry, meant to be 2. My bad. Thanks, Karen. Oh, it's supposed to be 1. My apologies. Sorry about that. My apologies. We're okay with that? My apologies. Yeah. Yeah, you got it? Yes, go ahead. It's always been on the major axis. And then you have to figure out what C is. So the formula to find C is this right here. A squared minus B squared. And you have to identify what A and B are, which are 5 and 3 respectively. And then work it out. You should get C is 4. And you gotta go 4 away from the center. In this case, 4 up, 4 down. And my apologies, was supposed to be 1 for the x coordinate of the vertices.
Because the denominator of the y is greater, so therefore that's what.
Right, exactly. Okay. Let's skip B for now. Let's keep moving. All right. So number 4, guys, given that graph, rearrange the equation so it's the standard form. Find those things. How long is each? So what you need to do in this case is divide everything by 36. Okay, does that make sense? Now in this case, which was major? Which was major? X, right? So the major axis will be horizontal. So where's my center? 1, -2, very good. I have to go 3 left, 3 right. Nope, too far. 2 up, and 2 down.
Oh, sort of, ah.
So your vertices are here and here. Your co-vertices the major axis is 6. The minor axis is 4. I'll see about that. If you're curious about the foci, CV root 5. So your foci, if you were to write it, would be, excuse me, 1, comma, no, 1 plus or minus root 3, comma, -2. So be right here. Okay.
So hopefully this dissects this as much as I can. The homework won't be quite like this because it'll just be the center be at 0, 0. But you guys will be ready once you start moving away from 0, 0 because we're doing some more advanced stuff. Kyle, go ahead.
Come different size, 1 plus or minus 3 seems fine.
True. I am just messing up. Thanks, Kyle. I don't know why I wrote root 3. No idea. You guys are keeping me sharp. Thank you. Appreciate it. Yes, 1 plus minus root 5. Sorry about that. Okay, we're good. All right. Cool. All right. Okay. I didn't even ask for it. I just wanted to do you guys. Okay. Let's look at more problems. Let's look at 5 and 6. Hold on. Any question on this at all? Phil's still copying? I'll wait. Yeah, go, Kieran. Well, no, so in this case,
Well, you want 1 on the side,
Yeah.
right? And so A's was reserved for the bigger denominator.
Yeah.
So A squared is 9 and B squared is 4.
Yeah.
So A is 3 and B is 2. Which
Excuse me. Okay. Let's move on to 5. Okay. If 3, 1 is a vertex and 5, 0 is a co-vertex, wouldn't this be your center? Right? Would that make sense as your center?
Also be. Yeah, it can also be.
Oh, wait. You're right. Sorry. No, my bad.
And it could be either.
No, because you need this to be a vertex. You need it to be longer. My apologies. It's gonna be right here. Yeah, my apologies. It'll be a 5, 1. It looks like an eye. Actually, we used to do like a fun art project with Conics back in the day, but I'm not sure about time for that. So this is gonna be at 7, 1. Guys, quiet please. 5, 2. So if you're asked to write an equation, what's your A value? What's your B value? So you're gonna say x minus 5 squared over 4. Because remember, you can do a squared on the bottom, and a goes with x. Y minus 1 squared over 1 equals 1. Yeah, good. It's up to you. So you're talking about doing x minus 5 over 2 squared. It's up to you. Doesn't matter. It's totally up to you. Yeah. Yeah, go ahead. Yeah. Okay. Go and try 6 and 7. I'll freeze my screen. And then we'll discuss. Let me go till what time? Yeah, go and try 6 and 7. I'll freeze the screen. And we'll share. Hope you guys got that.
So even if you're not asked to graph, it still helps to do a graph like the number 7 in that case. You're asked to write equation just to visualize it. Of course, graph is provided, but for number 6, dividing by hundreds, get 1 on the right side. That's again standard form. Obviously, the major axis is horizontal. So you're going 5 left, 5 right from the center. Center should be -2, take it correctly. I think that's all good. Vertices make sense. Co-vertices should make sense too. You're going 2 up, 2 down from the center. And yeah, center's -2, so that should be fine for 7. You're going 2 up, 2 down, so the major axis is it's vertical. You're only 1 left, 1 right. Center's at 1, 1. Yeah, we're okay with that.
Yeah, good. Yeah, of course. Yeah. Okay. So we kind of already talked about this, so this shouldn't be this is more just words. Are you guys still copying? Can I move on? Yeah, okay, let's move on. So yeah, girls, can you stop talking? Okay. So we already talked about this, right? Like, I mean, I'm not gonna do this demonstration, but if you were to take a piece of string and actually draw it works correctly and connect the string to this and this, and then kind of move this around. Of course, like the string would change, right? So if you divide this string into 2 separate segments, D1 and D2, D1 plus D2 is always an equal to the string, which is a constant, right? So this is just more informative stuff that I've already talked about with you guys about a half hour ago. So that's just what we're noticing here. Obviously, how long is the major axis? 2a. So string is also 2a. If we were to actually do that, like if I were to actually take a piece of string, connect this, and connect this, those 2 segments would have the 2a. So that would be the length of the string. Yes, it's placed dependent on the vertex. I already talked about this, so it's nothing too crazy. The relationship between A, B, and C I already talked about as well as this.
You need the last bit at the end for that to actually sound good.
No, because what you're doing is you're connecting, the purple's connected to one F1 and the pink's connected to the other focus. Right. Right. Yeah, and then for number two is just going to be C squared. I already explained it to you guys, but if you have like this right here, say call it 0, comma B. And if you did, it calls like D1 and D2. Remember, that's negative C, comma 0. And if you actually go through the calculation and work it out, you'd wind up getting this. I'm not going to go through it again, but you would get that if you were to work it out. So C squared equals A squared minus B squared. I'll wait for you guys to get caught up. Then we'll move on to pages 10 through 12. Okay. So again, distance between two vertices is 2a, the two co-vertices 2b, the foci 2c. R1 plus R2, I call it D1 plus D2 all equals 2a. A squared equals that, or C squared equals A squared minus B squared. So it's more of the same stuff. Nothing too different here. I want to go down to a word problem. That might be better. And actually, let's do this. Excuse me. Let me skip around. Let's go to page 11, number 6. Yeah, some of this is getting kind of repetitive. So we're going to skip around a little bit because we already done problems like 3 and 4. And we'll come back to the word problem if we have time. Let's look at 6. Okay. So again, we have to complete the square. Yeah, I know. I know. Okay, here's what you do, guys. Guys, quiet, please. Thank you. I'm gonna kind of separate out like this in a way. Okay. Here's what you gotta do. Factor out the 9. Factor out the 4. So you gotta be very organized about it. As long as you're organized about it, it's not that bad. Now you do complete the square. What's happening to the square, guys? 1. What's half 4 then squared? 4, right? So what it enables you to do, enables you to rewrite this as x minus 1 squared, right? And this could be rewritten as 4 times y plus 2 squared. However, what must I add to the right side to keep it balanced? This is tricky.
9 and 16.
9 and 16. Yes. 9 and 16. You do not add 1 and 4, guys. Because what did I truly introduce to the left side? I didn't introduce 1. No way. I introduced 9. Put that 9 back in. I introduced 9, not 1. What did I introduce over here? Did I introduce 4? No. I introduced 16. 4 times 4 is 16. So we're going to keep it balanced. If I distribute, I'd better get back to the same thing. Right? You always have to be able to retrace your steps in algebra. So you really added 9 and 16, not 1 and 4. So in this case, I get 36 on the right side. And then I divide everything by 36. So you get x minus 1 squared over 4 plus y plus 2 squared over 9 equals 1. Okay? We're okay about that? All's good? Okay. Cool. Okay. And then I trust you guys can graph it, so I'm not too worried about that. Why don't you guys try number 7? Try completing the square on that one. Okay, does that make sense what I just did? Right? Yeah, and then again, I trust you guys can graph it just fine. Obviously your ace, your yeah, well, so root 12 is roughly between two integers. Exactly. So let me keep this part and erase everything else, because I think you guys get what I just did. Okay. We have to go 6 up, 6 down. Guys, quiet, please. 3 point something left. Oh, geez. Okay, not the best looking oval, but it's okay. So I got my center. That's easy. My vertices, I'm going to say, is -3, comma 7. -3, comma -5. My co-vertices, I'm going to say, is -3 plus or minus 2 root 3, comma 1. Because root 12 is 2 root 3. And my foci, c squared equals a squared minus b squared. C squared is 24. C is root 24. C is 2 root 6. So that's going to be -3, comma 1 plus or minus 2 root 6. I'm just kind of guessing where it is. So anyway. Does that make sense? Okay. I kind of done a lot with you guys today. Let's do one more, just number 8. I won't do page 12 because we're still gonna spend more time with this next week. So let's do one more problem. And that's almost the end of the day. You guys have been very patient. I appreciate it. And we could revisit some of this stuff. Yeah, I didn't realize how many problems are here. So it's a lot. But we can always do more of this next week too. But let's look at number 8 here. So your foci right here. Where's the center, guys? Perfect. So C is 2. 2A is 16. So what's A going to equal? 8. And remember, the foci is on the major axis. So where's my vertices? On the X or Y axis? Or is it horizontal or vertical? Horizontal. Good. Yeah, thank you, Thomas. Yeah. And remember, C squared equals A squared minus B squared. Now you see why it's called analytical geometry. You have to get a little more analytical here. 4 equals 64. So B squared is going to be 60.
It's 16, I think.
Did I make a mistake?
Oh, no, you didn't have one.
No, I've been making mistakes all day, so please let me know.
No, you're right.
Okay, cool. I'm glad I'm right for a while. All right, so B is root 60. Which is what? 7 point something, right? So I don't need a graph necessarily, but I now have enough to make the equation, right? X minus 2 squared over 8 squared, or over 64, plus y squared over 60 equals 1. That's kind of hard to read. Let me put equals 1. So your homework will be much easier. Homework's going to look like this. So it's going to do the 9-4 problems. There are some word problems too. Kind of see how that goes. It should be pretty straightforward. So, and we're going to stop there for today because I've got like 2+ hours of conferences coming up. So, yeah.